I got this book from the library. It's Atom, Journey Across the Subatomic Cosmos, written by Isaac Asimov. Here's a picture of the dude. Looks to be pretty chill to me. Today is November 20th, 2016. This is on page 187, Nuclear Fusion. Both natural radioactivity and nuclear fission affect nuclei with large mass numbers, bringing about a change towards nuclei of intermediate mass numbers and greater stability. In the process, mass is lost and energy is produced and dissipated. It is also possible for nuclei with small mass numbers to combine with each other or fuse, that is, melt together, forming a somewhat more massive nucleus. This too represents a change toward nuclei of intermediate mass numbers and greater stability. Here too, mass is lost and energy is produced and dissipated. The energy, this is on page 89, it went into specifics on the earlier page, that's why I ignored it. The energy that can be produced by nuclear fusion proved of crucial importance to an understanding of the universe even before the other energy source, nuclear fission, was discovered. The story goes as follows. Ever since the development of the law of conservation of energy in 1847, scientists had been wondering as to the source of energy radiated by the sun. This radiation had been occurring throughout human history, and geological studies made it plain that it had been occurring long before human beings had evolved. No source of energy known in the 19th century, the 1800s, could account for the sun's having kept burning for more than 100 million years or so, which proved to be a conservative estimate. In the first decade of the 20th century, scientists began measuring the ages of rocks and of meteorites by the amount of radioactive change that had taken place in them. It soon appeared that our solar system, including the Earth and the Sun, was several billion years old. The best current figure for its age is 4.5 billion years. By 1910, it was recognized that nuclear energy was more powerful than any other that had been considered. In 1920, the British astronomer Arthur Stanley Eddington, who lived from 1882 to 1944, suggested that the sun's energy might be derived from the fusion of hydrogen to helium. This suggestion looked better as the decade progressed. When Ashton worked out the notion of packing fraction, it became clear that the fusion of hydrogen to helium was the only simple nuclear reaction that could possibly yield enough energy to power the sun. Then, in 1929, the American astronomer Henry Norris Russell, from 1877 to 1957, worked out the chemical composition of the sun by a careful study of its light spectrum, and discovered that it was mostly hydrogen. About 90% of the atoms in the sun are hydrogen and 9% are helium. All the other elements together make up the remaining 1% of the atoms. This meant that not only was the fusion of hydrogen to helium the only simple nuclear reaction that could yield enough energy, it was the only significant nuclear reaction that could take place at all. It was hydrogen fusing or nothing. Few statements, a few things I want to point out, which is why I read this. Number one, it was a suggestion that the sun was nuclear powered by hydrogen fusing to helium. It was a suggestion. There was no discovery of the sun being powered by fusion processes. To this date, nobody has seen the interior of the sun, so they don't actually know what's going on in there. It's all suggestions and assumptions. Let astronomers really come to grips with what that means. They're assuming things to be true based off of very little information, and they took that assumption and they made it true for almost 100 years now. Mind you, this is also before the discovery of incredibly powerful events called active galactic nuclei were discovered, and the entire field of radio astronomy didn't even exist yet. The actual locations for where fusion reactions take place are in active galactic nucleuses. That's where fusion happens. The two big jets that come outside the central regions, radio galaxies, that's where fusion happens, not inside of stars. And the all or nothing type atmosphere attitude that they had, it was hydrogen fusion or nothing. Well, that just solidified it. They had no other alternative to keep the sun hot and shining for many billions of years, millions of years, whatnot. They just had no other idea out there. There were no alternatives. So instead of keeping an open space, saying, well, we have this idea, and we have this idea, and we have this idea, they didn't give themselves options. They said, to hell with all the other ideas. It has to be hydrogen fusion, and that's it. So it became the dogma. And everybody started writing up all these equations to try to prove how much the sun was fusing all this hydrogen to helium. And nobody questioned it. Because the spectroscopy of the star itself, they took measurements of the light coming from the stars, and they said, well, the light measurements say it's 90% helium, or no, 90% hydrogen, 9% helium, and then they didn't even go inside the interior of the star either. They just said, well, look, it's all hydrogen. And that was that. They don't know what's inside the sun. They're making assumptions again. Another assumption they made is that the sun and the earth are the same age because of the nebular hypothesis. So what they did, they didn't actually date the sun. They didn't. They never radiometrically dated the sun. They radiometrically dated the earth. This is exactly what they did. They radiometrically dated the earth. They said, wow, the crust of the earth is at least 4.5 billion years old, because they radiometrically dated the meteorites that came down there. They radiometrically dated those, and they said, well, meteorites must have formed at the same time as Earth, and since the Earth and the meteorites and the sun all formed at the same time, that means the sun has to be 4.5 billion years old. It had nothing to do with the geological stuff at all. What it really was is that they were taking measurements and then clumping them all together into a big model to make all the solar system objects the same age, including the sun. And they said, well, the geological records, there was heat on the Earth. That's why the sun was always there. Not exactly. The Earth could have been orbiting another star in its past. And how long would it take the Earth to get adopted by another star? Maybe 2 to 5 million years as it traveled through the galaxy and then was adopted by another star and orbited that for a little while. It's not that hard to imagine. Maybe that's why there were extinctions. Major extinctions, because the Earth was changing orbits. But anyways, I just want to point that out. With this theory, you can look at a lot of the assumptions that people make. Don't realize that they're making, though. As well, a lot of the history I've been learning about how science progressed. It wasn't really much of a progression per se. What it was is, this is how everything is. All the other people that have different ideas, we got to kick those people out because this is how it really works. And then they gave themselves the awards and the Nobel Prizes, and they made these cult-like followings inside of those in-groups. And since then, if anybody had any idea that, say, the sun wasn't a fusion reactor, that it is actually just plasma recombination, the plasma is like in a feedback loop, perpetual, or not a perpetual, but a long-scale feedback loop of ionizing and recombining repeatedly because of the gravitational field. That instead of thinking like that and giving alternatives, they said, if you have an alternative, get the hell out. We won't publish your papers. We'll peer review you out of existence. And that's where science is today. And I guarantee you, I'll bet the farm, that all these fusion reactors they're going to make, the tokamaks and all that shit, it's all going to fail. Because they have no idea how fusion works. Alright. Hopefully this talk helps people out. And look for those assumptions that these science fiction writers and science writers are making, because you're not going to see them. They're not going to write them in the book. You have to learn how to spot them out. All right, later.